can't tell from the outside, but there's exciting research going on inside this building in East Liberty. This is the Human Engineering Research Laboratories at Bakery Square. It's run by the Department of Veterans Affairs and the University of Pittsburgh. Here, in these large rooms, you'll find the latest cutting-edge technology. Technology that's helping veterans and others with disabilities lead independent lives.
Then you put another bolt just like that one in parallel in front, and that would be your gas spring would mount on that one.
Dr. Rory Cooper runs the lab.
We're here because people with disabilities have not achieved full inclusion. So we're here to help people find technologies that will help them get to work, to be fully mobile in the communities.
Dr. Cooper knows the issue well. In 1980, while serving in the U.S. Army, he suffered a devastating accident in Germany.
I had a knee injury. One day I was riding my bicycle and I got sideswiped by a bus and hit head-on by a big Mercedes semi-truck and broke many ribs and my clavicle. And most severe injury was a spinal cord injury, and that's caused paralysis of my lower extremities.
Cooper's life was forever altered, but the injury led to a new phase in his life. He went on to get his doctorate in engineering and was later hired by Pitt to help start the research lab. It was a job where he could make a difference.
Many people don't understand what it means to have a disability. People sort of project onto veterans or onto people with disabilities what their perceptions are of what a person with a disability can and can't do. When in reality, they need to do is make the assumption that they can do pretty much anything so that they can learn and work collectively to find solutions.
And solutions are what this lab is all about.
The idea is that wheelchairs could be better, prosthetics could be better. Now we've done a lot of work recently in robotics and cognitive aids and even modifications to the environment, where grab bars need to be and how tall toilets need to be. We try to work on all of those areas.
Even in the kitchen, where something as simple as preparing meals can be a real challenge.
This kitchen is designed for people with Alzheimer's and brain injury.
This is the queuing kitchen, where specially designed computer programs provide cues or step-by-step instructions for cooking things like pasta.
When I click next, the program will give me my first instruction on how do I get started with making pasta.
Take out cooking pot from the lighted cabinet. Take out pasta from the transparent cabinet. Fill the cooking pot with water from the water faucet. Turn the faucet off. Place cooking pot on the stove. Turn on the stove.
This program is ideal for someone with cognitive or memory loss problems. But for those who need more help, there's this futuristic device called the Kitchen Bot. The Kitchen Bot can turn a faucet on and off. It can also open cabinets and drawers and operate appliances. It's a sophisticated instrument that moves up, down, and sideways, and can be programmed for a specific or a group of functions.
And it's kind of evolving as we collect more data and working with older adults, group homes, so individuals born with disabilities or acquired brain injuries, and also with veterans.
Down the hall, in another lab, researchers are helping people who have mobility problems.
It's called StrongArm, and this device is used to transfer wheelchair users from the seat to another surface, such as a shower bench, a toilet, or even the bed. So what I'm doing with StrongArm is I'm bringing it over, then I'm going to strap on the sling onto the hooks of the StrongArm. Now we're going to raise up the arm, and we're just going to transfer her over. Now that we have her in position, that's our transfer using StrongArm.
StrongArm can lift up to 250 pounds. But like KitchenBot and the queuing kitchen, modifications are still needed before they are ready for commercial use. And because they are prototypes, all parts are custom made. That's done here in this high-tech machine shop.
Now this is precision work, isn't it?
Absolutely. All our tools are electronically zeroed in. we're able to get very high accuracy with a machine like this. We can use this type of machine to make anywhere from 1 to a couple hundred of certain devices or parts on this machine.
Functionality and design are important,
So from translation mode, we go to finger mode from here.
but so is input and feedback
Can we pick up that
from
can
people
of
like
V8?
Matt Hannon.
Can you hand me that can of V8?
In 2007, while serving as a Marine in Iraq, Hannon broke his back during a raid against Al-Qaeda.
It took me about 18 months to realize the severity of my injury, and by then permanent damage was done. After approximately 8 back surgeries to where I have my faculties, the recovery process was several years to get me to where I'm at now.
And right now, Hannon is studying at the University of Pittsburgh. He also found meaningful work at the Human Engineering Research Lab, where he's a research assistant.
I wasn't quite sure what I wanted to do, but I was interested in helping my fellow veterans with disabilities as well as others. And that's essentially what this facility does. So it gives disabled veterans another crack at life.
And it's a full life, and a job shared with colleagues, filled with the satisfaction of supporting others.
My mission is to, one, see people with disabilities and veterans with disabilities succeed. And on the other hand, that we can create and train the next generation to create technologies and new techniques. For me, it's rewarding. I'm one of those fortunate people that my hobby, my interests, and my work all coincide.